This is Math 96, Quiz Topics number 2. Power, product, and quotient rules with negative exponents. I thought it would be a good idea to look at these rules individually first before we put them together into one problem. To illustrate the power rule, we have 5x to the negative 4, y to the third, raised to the negative 2 power. What we do is we apply this negative 2 exponent to each of the bases inside. And so we would have 5 to the negative 2, x to the positive 8, y to the negative 6. Then we need to simplify that. And so anytime we see a negative exponent, that means to move this term to the other end of the fraction. Right now, all these are on the top of a fraction, so we can picture that as being over 1. And so the 5 needs to move down to the denominator of the fraction and become 5 to the positive 2 power. The x to the 8th stays in the numerator, and the y to the negative 6 moves down to the denominator and becomes y to the positive 6. And so if we simplify the 5 squared in the denominator, that would be 25. And so on top we still have x to the 8th, and on the bottom 25, y to the 6th. And that would be how that first one simplifies. Okay, now taking a look at the product rule with negative exponents, 9xy to the negative 5th times negative 3x to the negative 3rd y to the 4th. Okay, we can multiply things that are alike, and so 9 times negative 3 would be negative 27. X times x to the negative 3, we add the two powers together. X really is x to the first, and so we think of adding the positive 1 and the negative 3 powers would make x to the negative 2 power. And then y to the negative 5th times y to the 4th would be y to the negative 1. All right, now we need to simplify this. A negative 27, the negative is not the exponent. It's in front of the 27. So that's still a negative 27 that would stay in the numerator of the fraction. However, these negative exponents would move the x and the y down to the denominator of that fraction, making them x squared and y to the first, or just y. And so that one becomes negative 27 over x squared y. Now let's look at the last part. So the quotient rule says that when we have two bases that are alike and we're dividing, we subtract the powers. And so this would be written as 2 to the 3 minus negative 2. I'm writing that out so you can see it. X to the 3 minus 5, and y to the negative 9 minus 1. Because if there's no exponent, that's really an exponent of 1. And so let's simplify each of these parts. 3 minus negative 2. Minus a negative is really the same as plus a positive. So this becomes 2 to the positive 5th. And then x to the negative 2. Y to the negative 10. Okay, 2 to the 5th would mean 2 times 2 times 2 times 2 times 2, which is 32. And then both of these will now move down to the denominator of the fraction because they have negative exponents. So this becomes 32 over x squared, y to the 10th. Okay, so now that we've looked at the power, product, and quotient rules individually, let's look at what happens when we put them all together. So here's our example. We have a fraction raised to a negative power and then multiplied by another term. And so we can do this one of two ways. We can either apply this negative exponent to each term inside, or we can try to simplify what's inside the parentheses first. In this case, I think it would make the problem simpler to simplify what's inside the parentheses first. And so let's do that. Let's notice that I have an a and an a to the fourth. And so let's use our quotient rule and make this negative 3 a to the 1 minus 4. Okay, we'll leave the 2 in the denominator. B to the negative 5 minus negative 2. And C to the 6th. So all this is inside those parentheses, and I haven't done anything with the negative 3 power yet on the outside. And I haven't done anything with this next term, so I'm just going to leave that the way it is. Okay, so now let's simplify what we have in the parentheses. So I've got negative 3 over 2 still. And then a to the negative 3. B, let's see, this would be negative 5 plus positive 2, so that would be b to the negative 3, and c to the 6th. Okay, all of that's still inside the parentheses with the negative 3 outside. 3, a to the negative 1, c to the 5th. Okay, so now let's apply this negative 3 exponent to each of the parts on the inside. So I have negative 3 raised to the negative 3 power, a raised to the positive 9 power, because I'm multiplying the negative 3 times this negative 3, b raised to the positive 9 power, and c to the negative 18 power, and 2 in the denominator to the negative 3 power. So I've applied the negative 3 now to everything inside, and then I'm multiplying by 3a to the negative 1, c to the 5th. And to make this into a fraction, I could just put this all over 1. Okay? And so then let's go ahead and multiply the two numerators together and the two denominators together to have negative 3 to the negative 3. I can combine the a to the 9th and the a to the negative 1. Because I'm multiplying these two, I add their exponents. So that would be a to the positive 8. B doesn't have anything to combine with, so it's still b to the 9th. I have c to the negative 18 and c to the 5th, and so those would combine to be c to the negative 13. And then on the bottom, the 2 to the negative 3 times 1 is just 2 to the negative 3. Okay, I'm getting really close. So now, any negative exponents I see, I want to move to the denominator to make them positive, and vice versa. So this becomes negative 3 to the positive 3 in the denominator. A to the 8th stays put. B to the 9th stays put. This c to the negative 13 moves to the denominator to become c to the positive 13. And in the denominator I have 2 to the negative 3. That will move up to the top. So 2 to the positive 3. Okay, the only thing remaining now is just to simplify the two numbers raised to a power. And so 2 to the 3rd becomes 8. A to the 8th, b to the 9th. And then negative 3 to the 3rd power would be negative 3 times negative 3 times negative 3 is negative 27. C to the 13th. And that is our final answer.